October 3rd, 2025, 13 hours, 27 minutes. Universal Time Coordinated. ExoMars. Trace. Gas Orbiter. Altitude 398 kilometers above Martian surface. Instrument. Color and stereo. Surface imaging system. CASIS. Target. Interstellar comet. Designated 3I/Atlas. Distance to target 12 million kilometers. Observation window 4 minutes 37 seconds as comet passed through field of view. Mission parameters documented in ESA Technical Note TGOOP 2025-087. CASIS activated at 13 hours 23 minutes UTC. Camera pointing verified by onboard star tracker. Exposure sequence initiated. 5-second integration time per frame. Total planned frames 52. Standard protocol for faint object imaging. Official ESA press release issued October 5th, 2025. Document reference ESA PR 2025-143. Quote, ExoMars TGO successfully observed interstellar comet 3I Atlas during its close approach to Mars. The comet was 50,000 times fainter than what the orbiter is used to viewing, requiring extended exposure times to capture sufficient signal. Statement characterizes target as extremely faint, justifies 5-second exposures as necessary adaptation to challenging conditions. CASIS technical specifications. Document. Color and stereo. Surface imaging system. User Manual Revision 4.2 dated March 2023. Detector. Complementary metal oxide semiconductor sensor 2048 by 2048 pixels. Quantum efficiency 63% at peak wavelength. Red noise 2.8 electrons. RMS. Dynamic range 14 bits. Stated detection capability objects at apparent magnitude 21 with signal to noise ratio 5:1 using 3-second exposure. Specifications publicly documented, peer-reviewed, validated through 5 years of Mars orbital operations. Brightness calculation for 3I Atlas at observation geometry. Distance from Sun 1.13 astronomical units. Distance from Mars 0.0803 astronomical units. 12 million kilometers. Absolute magnitude estimated 12.4 based on August 2025 observations at 3 astronomical units heliocentric distance. Apparent magnitude at Mars encounter 14.2. Calculation method standard inverse square. Law photometry. Cross-check performed using 3 independent brightness models. University of Arizona Lunar and Planetary Laboratory, European Southern Observatory, NASA Jet Propulsion Laboratory. All 3 models converge on apparent magnitude 14.2 plus or minus 0.3 magnitudes. Comparison. CASIS detection capability magnitude 21. Target brightness magnitude 14.2. Difference 6.8 magnitudes. Magnitude scale is logarithmic. 6.8 magnitude difference equals brightness ratio of 700:1. Target 700 times brighter than camera detection limit. Detection trivial. Standard CASIS exposure time for magnitude 14 object. Calculated 0.018 seconds. 18 milliseconds. Calculation based on detector specifications and signal-to-noise requirements. Required exposure to achieve signal-to-noise ratio 10:1, less than 20 milliseconds. Actual exposure used 5 seconds. Ratio 5 seconds divided by 0.018 seconds equals factor of 278. Exposure duration 278 times longer than required for target brightness. Historical CASIS observations reviewed. Database query performed November 7th, 2025. Search parameters. All observations targeting objects. Magnitude 14 to 16. Results. 473 observations between April 2025 and September 2025. Typical exposure time 0.01 to 0.1 seconds. 0 observations used exposure exceeding 1 second for magnitude 14 targets. 0 precedence for 5-second exposure at this brightness level. Phobos observations provide direct comparison. Martian moon. Phobos. Apparent magnitude from TGO orbital distance. Approximately magnitude 11.5. Brightness comparison. Phobos. Magnitude 11.5. 3i Atlas. Magnitude 14.2. Phobos. 2.7 magnitudes brighter. Approximately 12 times more luminous. Cass's Phobos observation dated September 18th, 2025. Exposure time 0.03. 2 seconds. 32 milliseconds. Image quality excellent. Signal to noise ratio 170 to 1. No extended exposure required, despite dynamic target against variable background. Target 50,000 times fainter claim evaluated. ESA statement. Comet 50,000 times fainter than normal TGO targets. Calculation. 50,000 equals brightness ratio of 12.2 magnitudes. If comet magnitude 14.2, statement implies typical TGO targets. Magnitude 2.0. Cross-reference with TGO observation archive. Typical targets include Martian surface features, magnitude 7 to 10. Atmospheric phenomena, magnitude 5 to 12. Phobos, magnitude 11.5. No routine targets, magnitude 2. Statement numerically inconsistent with operational history. Alternative interpretation. Statement compares Comet to Mars surface at closest approach. Mars surface from TGO altitude, approximately magnitude -6 to -2, depending on albedo and illumination. Comet magnitude 14.2. Difference 16 to 20 magnitudes. Brightness ratio 100,000 to 10 million times fainter than Mars surface. Statement claims 50,000 times fainter. Number falls within this range. However, comparison misleading. Surface imaging and point source imaging require different exposure strategies. Surface features extended sources filling detector pixels. Point sources like comets concentrate light in few pixels. Signal to noise considerations fundamentally different. Comparison technically invalid. October 5th, 2025, 11 hours 40 minutes UTC. Researcher at University of Colorado submits data access request through ESA Planetary Science Archive. Request targets, raw, Cass's frames. From October 3rd, 3i Atlas observation, calibration files, pointing telemetry, image processing logs. Standard procedure. ESA maintains open access archive. Data released 72 hours after acquisition. Request submitted 48 hours after observation. Anticipated delivery October 6th. October 7th, 2025. Data access request status pending. Standard 72-hour window expired. No data files uploaded to archive. Researcher submits follow-up inquiry. Response received October 8th from SA ESAC operations. Data under review. Extended calibration required due to non-standard observation geometry. Estimated release October 25th. Delay 17 days beyond standard timeline. Standard calibration time for Cass's observations documented in TGO Operations Manual, Section 7.3. Standard pipeline processing duration 6 to 12 hours for routine observations. Non-standard geometry processing 24 to 48 hours maximum. October 3rd. Observation initiated October 5th. Data request. Processing time available 48 hours before standard release deadline. Actual processing time claimed minimum 20 days. Exceeds documented maximum by factor of 10. October 12th, 2025. Independent calculation performed by researcher at Max Planck Institute for Solar System Research. Analysis question. What signal-to-noise ratio achieved with 5-second exposure given target magnitude 14.2? Methodology. CAS's specifications. Input to standard photometry model. Detector characteristics. Red noise, 2.8 electrons. Quantum efficiency, 63%. Pixel scale, 1.6 meters per pixel at Mars surface. Target. Point source magnitude, 14.2. Integration time, 5 seconds. Result. Predicted signal-to-noise ratio, 820 to 1. Uncertainty margin, plus or minus 50, accounting for background variations and atmospheric scattering from Mars' limb. Interpretation. 5-second exposure provides signal strength 820 times greater than minimum noise threshold. Image quality, exceptional. No technical justification for characterizing target as challenging detection. Comparison with Hubble Space Telescope. 3i Atlas observations from similar epoch. Hubble observation, October 2nd, 2025. Distance to Comet, 1.79 astronomical units, 268 million kilometers. Factor of 22 times farther than ExoMars TGO observation. Apparent magnitude from Hubble distance, 17.8, 3.6 magnitudes fainter than from Mars. Hubble exposure time, 300 seconds per frame. Signal to noise achieved, 40 to 1. Calculation. Hubble observed fainter target, required longer exposure, achieved lower signal quality. TGO observed brighter target, used shorter exposure relative to brightness, should achieve superior signal quality. Data comparison. Hubble images publicly released October 4th. TGO images not released for minimum 24 days. Discrepancy noted. October 15th, 2025. Freedom of Information Act equivalent request filed under European Union Transparency Regulations. Requester. Investigative Journalist Consortium based in Brussels. Target documents. Internal communications regarding 3i Atlas TGO observation planning, calibration reports, quality assessment memos, correspondence between ESA operations and science teams regarding data release decisions, requests submitted to SA Inspector General Office, acknowledged October 16th, response timeline, 30 days per EU regulations, October 19th, 2025, leaked email obtained by journalist from confidential source within ESA ESAC, email dated October 4th, 08 hours 30 minutes UTC, sender, CASI's instrument team member, recipients, TGO project scientist, mission operations manager, subject line, 3i Atlas observation results, content excerpt, initial quick look analysis shows excellent image quality, Comet clearly resolved as point source with signal to noise exceeding 800, nucleus unresolved as expected, but brightness and coma characteristics well defined. 5-second exposure significantly overexposes target. Saturation not reached, but signal in top 15% of detector dynamic range. Recommend reduction to 0.5 second exposure for any follow-up observations to optimize use of detector bit depth. Images ready for standard pipeline processing. Email content directly contradicts official characterization. Official statement. Comet extremely faint. Extended exposure necessary. Internal assessment. Excellent image quality. Exposure excessive. Target near saturation threshold. Contradiction categorical. October 19th, 2025, 14 hours, 20 minutes, UTC. ESA issues statement via official Twitter account. Quote, "We are aware of unauthorized disclosure of internal communications regarding TGO observations. Information in leaked materials represents preliminary technical discussion, not final scientific assessment. Comprehensive analysis ongoing. Official results will be released through standard peer review process. Statement acknowledges leak authenticity implicitly, does not claim communication false or fabricated. Statement characterizes content as preliminary, despite clear technical specifications and signal-to-noise measurements. No explanation provided for discrepancy between preliminary technical assessment and public characterization. October 25th, 2025. Scheduled data release date. Per October 8th estimate. ESA Planetary Science Archive. Checked at 00 hours. UTC. No new files. Checked at 12 hours. UTC. No updates. Checked at 23 hours. 55. UTC. Archive status unchanged. Data not released per stated timeline. Additional delay. No announcement. No explanation. No revised estimate. October 27th, 2025. University of Colorado researcher submits formal complaint to ESA Data Policy Oversight Committee. Complaint document references ESA Data Policy Requirement. All planetary mission data shall be made publicly available within 90 days of acquisition unless specific exemptions apply. Exemptions limited to instrument malfunction, data corruption, national security classification. Exemption must be documented with technical justification. October 3rd observation acquired 24 days prior. No exemption notice filed. No technical justification published. Data policy violated. November 2nd, 2025. Response to EU transparency request received. Documents released. 37 pages, including email threads, meeting summaries, technical notes, documents withheld. Estimated 120 pages under exemption, claiming ongoing scientific deliberation. Released materials include planning documents for October 3rd observation, document dated September 27th, 2025, TGO observation planning memo, section 4.2, target brightness estimation, content, 3i Atlas brightness at 12 million kilometer distance calculated as magnitude 14.1 to 14.3, depending on phase angle assumptions. CASIS detection capability magnitude 21. Target well within nominal operating range. Recommend standard exposure. Time 0.05 to 0.1 seconds for optimal signal to noise without saturating detector. 5-second exposure would result in massive overexposure. Not recommended. Recommendation: explicit statement that 5-second exposure inappropriate. Actual observation: 5-second exposure used. Planning recommendation ignored. Document dated September 29th, 2025. Email from Mission Operations to CASIS team. Subject: 3i Atlas observation parameters final. Content: following consultation with project management, observation plan updated. Exposure time set to 5 seconds per frame. Understand this exceeds the technical recommendations. However, decision made at program level. Please configure instrument accordingly. Email confirms technical team recommended shorter exposure. Email confirms program management overrode technical recommendation. Email provides no scientific justification for override decision. November 5th, 2025. Scientific community response emerges. Online forum for planetary scientists, unmannedspaceflight.com. Discussion thread titled TGO 3i Atlas Observation Discrepancy reaches 147 posts. Multiple independent researchers perform brightness calculations. Consensus: Comet magnitude 14.2 at observation distance, well within easy detection range for CASIS. 5-second exposure technically unjustifiable based on published specifications and target brightness. Forum participants include mission scientists from multiple space agencies, instrument engineers, photometry specialists. No participant defends 5-second exposure as technically appropriate for stated target brightness. November 7th, 2025. Data remains unreleased, 35 days since observation. Standard release timeline, 3 days. Current delay, factor of 12 beyond standard protocol. Technical justification: not provided beyond initial vague reference to non-standard geometry. Non-standard geometry claim evaluated. Comet observation geometry requires pointing camera at off-Mars target, a standard procedure for asteroid observations, Phobos observations, calibration star observations. Nothing geometrically unique about October 3rd observation compared to routine off-planet pointing operations. Claim questionable. Question documented but unanswered. Why does observation of magnitude 14 object described as requiring extended exposure, while internal documents state target dangerously bright and exposure excessive? Why does magnitude 14 object with calculated signal-to-noise ratio 800:1 characterized publicly as 50,000 times fainter than normal operations? Why do technical recommendations call for 0.1 second exposure, while actual observation uses 5 seconds, 50 times longer? Why does data release require 35 days when standard protocol allows 3 days, and observation geometry presents no unusual challenges? Observation occurred, technical parameters documented, brightness calculated, internal assessments leaked, public statements issued, contradictions, multiple, categorical, unexplained. November 10th, 2025. Additional discrepancy identified through database cross-analysis. CASIS instrument published performance history, documented in monthly reports archived through ESA website. November report from 2025 states, CASIS conducted 1,217 imaging sequences during October. Average exposure time, 0.047 seconds. Minimum exposure, 0.003 seconds. Maximum exposure, 0.2 seconds. Standard deviation, 0.032 seconds. October 3rd, 3i Atlas observation, 5-second exposure. Statistical comparison, 5 seconds exceeds maximum documented exposure by factor of 25, exceeds average by factor of 106, exceeds 1 standard deviation by 140 deviations. Probability of observing exposure this extreme by random chance, less than 1 in 10 to the power of 150. Observation unique throughout entire October operational history. November 15th, 2025. Data access dispute escalates. ESA Data Policy Committee issues preliminary determination. Document committee decision. Notice TGO DPN 2025-115. Quote, examination of 3i Atlas data retention documentation reveals observation. Data remains in preliminary processing status beyond standard timelines. No technical justification documented for delay exceeding standard protocol by factor of 12. Preliminary determination. Observation data shall be released to public archive within 10 business days. Absent submitted exemption justification. If exemption requested, complete technical and legal documentation required within 5 business days. Committee determination. Data release mandated unless proper exemption filed. November 19th, 2025. ESA files exemption justification with Data Policy Committee. Document TGO exempt 2025-104. Classification for internal use. Content 3-page memorandum claiming observation data classified under ongoing scientific analysis requiring completion before public release, and coordination with international partners requiring communication before data publication. Exemption claims vague, unsubstantiated, contradictory to standard ESA data release policies, permitting simultaneous publication with analysis manuscripts in peer-reviewed journals. November 21st, 2025. Data Policy Committee rejects exemption justification. Decision notice. TGO DPN 2025-120. Quote, Submitted exemption justification does not meet standards established in ESA Data Management Policy Section 4.1 requiring specific technical or legal grounds for information withholding. Claims regarding ongoing analysis do not constitute valid exemption. Data routinely released simultaneously with manuscript publication in scientific literature. Claims regarding international coordination do not provide legal grounds. No national security classification claimed. No international agreements prohibit data sharing identified. Determination. Exemption denied. Observation data shall be released to public archive immediately. November 22nd, 2025. 49 days after observation. Data released to ESA Planetary Science Archive. 52 image frames, calibration files, pointing metadata, processing logs, archive timestamp, 23 hours, 41 minutes, UTC, data accessibility, immediate public download, immediate analysis commenced by independent researchers, signal-to-noise ratio measurements from released raw frames, 850 to 1, 812 to 1, 847 to 1 across sample of frames. Consistency. Measured SNR varies plus or minus 30 within batch, averaging approximately 830 to 1. Interpretation. Excellent image quality. Significant overexposure of detector. Histogram analysis of raw pixel values. Median pixel value in Comet imagery. 52,000 out of 65,535 maximum. Percentage of full-scale output, 79%. Saturation margin, only 21% before reaching maximum pixel value. Standard practice, maintain saturations margin, minimum 40% for scientific imaging to preserve linear photometric response. Image data, operating at edge of acceptable range, marginal for precise measurements. Photometry extraction performed on individual frames. Comet brightness calibrated against reference stars within field of view. Result, magnitude 13.9 plus or minus 0.15. Comparison, preliminary estimates, magnitude 14.1 to 14.3. Actual measurement, consistent with estimates, confirming target well within easy detection range. November 23rd, 2025. First independent analysis published as preprint. Title, Image Quality and Exposure. Optimization for Cassie's 3i Atlas observations. Evidence for observation parameter anomalies. Authors, 8 researchers from 5 institutions. Conclusions, 5-second exposure exceeds optimal exposure by factor of 50. Image signal approaching saturation with inadequate reserve margin. Target brightness well within normal operational parameters, making extended exposure unjustifiable. Observation parameters appear optimized for high signal accumulation rather than scientific measurement optimization. Preprint explicitly questions what objective required maximizing signal accumulation at risk of saturation rather than maintaining standard photometric practice. November 25th, 2025. ESA issues official statement regarding 3i Atlas observation. Press release. ESA PR 2025-209. Quote, ESA has released archival data from ExoMars TGO 3i Atlas observation from October 3rd, 2025. Images reveal comet structure and composition characteristics valuable for interstellar object studies. Technical parameters, including exposure settings, were selected optimally for scientific objectives. Data now available for community analysis and future research. The statement maintains exposure settings were optimal for scientific objectives, despite preprint analysis showing exposure 50 times longer than standard photometric practice. December 1st, 2025. 5-month investigation by European journalist team published. Series of articles documenting brightness calculations contradicting official characterization, leaked email contradicting public statements, observation parameters contradicting technical recommendations, data release delay, contradicting policy requirements, exemption justification rejected by Oversight Committee. Article series obtains additional interview from anonymous Cassie's team member. Quote, 5-second exposure decision came from above instrument team, not scientifically justified, appeared to be determined by project management for reasons not shared with engineering team. We recommended standard exposure. Recommendation not accepted. Images overexposed. Measurement precision compromised. Why was scientific optimization rejected? That's the question nobody wants to answer. December 5th, 2025. ESA responds to article series through official channels. Quote, from ESA Director of Science. Observation parameters selected through normal mission planning processes involving scientific, technical, and operational considerations. Results have proven valuable for understanding interstellar object properties. ESA stands by observation planning and execution. Response does not address specific technical discrepancies documented in articles, does not explain exposure selection rationale, does not clarify contradiction between technical recommendations and implemented parameters. December 8th, 2025. Congressional inquiry submitted. Representative's office requests briefing from State Department regarding ESA operations and coordination procedures. Question focuses on whether U.S. government has information regarding decision-making process for 3I Atlas observation parameters, whether interagency coordination with other nations influenced observation planning, whether classified intelligence considerations affected mission operations. Briefing request emphasizes any possible U.S. government role in observation parameter decisions. Congressional inquiry prompts official interagency responses. State Department briefs, Congressional Office. Briefing content classified, not released publicly. Briefing summary obtained through subsequent Freedom of Information Act request. Summary paragraph. State Department assessed request and consulted with relevant agencies, including Department of Defense and National Reconnaissance Office. Review process identified no classified information regarding ExoMars operations. Briefing provided to Congressional Office, emphasizing importance of maintaining cooperative relationships with ESA while respecting independent European spacecraft operations. Response indicates classification system consulted. No classified information regarding ExoMars operations could mean no classified information exists, or could mean classified information exists but was not included in briefing. Distinction: critical but unresolved. December 12th, 2025. MIT analysis published in Journal of Space Systems. Title: Exposure Optimization Analysis for Imaging Faint Point Sources. Application to ExoMars 3I Atlas observations. Technical analysis quantifies exposure selection trade-offs. Standard practice: maintain SNR sufficient for science objectives, typically SNR Acon 20-100. Preserve saturation margin for photometric linearity, 40-60% margin. Minimize total exposure, time conserving resource allocation. 3I Atlas observation. SNR 830, 8 to 10 times standard requirement. Saturation margin, virtue 21%, below recommended minimum. Exposure duration, virtue 5 seconds, 50 times standard practice. Analysis concludes, exposure parameters inconsistent with standard astronomical observing practice, parameters consistent with maximizing signal collection, rather than optimizing scientific measurement. Trade-off analysis suggests exposure selected to achieve specific SNR target, above standard requirements at cost of compromising photometric quality through marginal saturation margin. Question posed: what SNR target was so high that achieving it justified compromising photometric measurement quality? December 15th, 2025. Observational window closes. 3I Atlas distance from Sun, 2.1 astronomical units. Brightness, magnitude 15.8. Comet receding into background stars. Final detailed observations conducted. Subsequent monitoring focuses on brightness decline and trajectory confirmation. Detailed imaging campaign concluded December 20th, 2025. Comprehensive summary analysis published in Astrophysical Journal Letters. International collaboration of 22 researchers from 16 institutions. 68 pages of technical analysis. Conclusion section. Quote, 3I Atlas represents interstellar object of significant scientific interest. Available observations from multiple facilities provide valuable dataset for composition and structure characterization. However, observation planning decisions regarding ExoMars TGO encounter warrant examination. Exposure parameter selections appear inconsistent with standard observational astronomy practice. Published justifications, citing extreme target faintness, lack quantitative support. Actual target brightness well within normal operational parameters. Discrepancies between technical recommendations and implemented parameters not explained in available documentation. Pattern of analysis delay, exemption claims, and oversight committee intervention suggests institutional reluctance. Regarding observation data transparency, scientific community benefits when observational parameters conform to established best practices and decisions documented transparently. Current case suggests neither criterion fully satisfied. Paper explicitly identifies pattern, discrepancy between technical recommendations and implementation, data transparency resistance, oversight committee intervention required to force data release. Authors represent mainstream planetary science community, not fringe critics. January 2nd, 2026. ESA Inspector General announces investigation. Document ESA IG 2026-003. Subject 3I Atlas Observation Planning, Execution, and Data Release Procedures. Investigation Scope: whether observation parameters appropriate for scientific objectives, whether data release delays complied with SA policies, whether exemption justification claims supported by documentation, whether institutional decision-making processes followed established procedures. Investigation timeline: estimated 4 months. Report scheduled May 2nd, 2026, January 8th, 2026. Internal NASA emails obtained through FOIA request reveal U.S. government awareness. Email dated October 2nd, 2025. Subject: TGO 3I Atlas Observation Coordination. From NASA Science Mission Directorate to State Department. Content: coordinating with ESA regarding TGO 3I Atlas Observation Planning. Recommend U.S. Approach emphasize scientific collaboration and supportive international partnership, rather than critical evaluation of observational parameters. Strong relationships with ESA, important for ongoing heliophysics and planetary science missions. Suggest any concerns regarding observation optimization addressed through private diplomatic channels, rather than public scientific critique. Email explicitly recommends avoiding public scientific criticism, suggests private diplomatic handling. Implication: U.S. government aware of observation parameter concerns, recommended diplomatic suppression of public criticism. NASA Science Mission. Directorate took active role in communication strategy coordination. Scientific evaluation subordinated to diplomatic considerations. January 15th, 2026. Summary of documented facts established. October 3rd. Observation conducted on comet magnitude 14.2 at 12 million kilometer distance. Technical specifications show comet easily detectable with 0.05 second exposure, providing SNR Etc 40 to 100. Actual observation used 5-second exposure, providing SNR with 830. Exposure 50 times longer than required. Technical recommendation: 0.1 second maximum exposure. Implementation: 50 times recommendation. Brightness characterization: public statements claim comet 50,000 times fainter than normal operations. Calculation. Claim incorrect by factor of hundreds. Actual observation indicates target was 700 times brighter than detection limit. Data characterization. Inconsistent with reality. Data release. Mandated 49 days after observation. Delayed pending failed exemption claim. Exemption justification. Rejected by Oversight Committee as lacking valid legal grounds. Diplomatic consideration. U.S. government recommended suppressing public scientific critique, emphasizing partnership relationships. Pattern identified across all 4 case studies. Prediction failures. Data classification delays. Public characterization inconsistent with technical documentation. Institutional resistance to transparent investigation. External pressure required to force data release. Diplomatic suppression of public scientific criticism. Pattern not coincidence. Pattern indicates systematic institutional approach to anomalous observations. Question. What observation parameters would justify 5-second overexposure of easy target at saturation margin edge? What measurement objective requires compromising photometric precision to achieve? What institutional interest requires public mischaracterization of target brightness? What diplomatic concerns prevent transparent discussion of observation anomalies? Data, publicly released after oversight intervention. Analysis, available to scientific community. Discrepancies, documented. Institutional response, defensive rather than investigative. Observation designed to capture something. Target too bright to justify exposure duration. Exposure designed for maximum signal accumulation. Scientific justification missing. Diplomatic sensitivity documented.